All right, we're going to do part 2 of our quiz corrections for adding and subtracting equations. I know number 6 was different because we used a different tests, but we're always upgrading. So, back to number 5. Robert mopped the floor. It took him 23 minutes. This was 8 minutes faster than the first time he mopped the floor. We're going to solve a subtraction equation to find out how much time he took to mop the floor the first time. All right, so this new time, we know it took him a total of 23 minutes. So 23 is going to be by itself. That was 8 minutes faster, which means if you take off 8 minutes, we would get to the 23 minutes it took him to mop this time. What is missing is how long it took him to mop initially, so the first time. So the way we could write this would be m minus 8 equals 23. You also have another way. You could do m minus 23 equals 8, in which case when you take the difference between what it originally took him to mop the floor, turn the phone off, there we go, and the second time it took him, we would end up with an 8 minutes difference. So you could also write it this way. So you had two options. And then the second part was simply to solve. So I'm going to solve the second one. It says to subtract. Wait, let me back up. Before I do that, let me put in my Great Wall of China so I know here's one side of the equation, here's the other side. Whatever I do to one side, I must also do to the other. That keeps it balanced and equal. Here we go. It says to subtract 23, so to do the opposite of that, I would add 23. That would give me m is equal to 31. Yep, so it would have taken him 31 minutes the first time to mop the floor. All right, now to the back. These are like questions you're going to see at the end of the year. So our May test, you know, the one for the state. So we're going to make sure we pay close attention to how we would do these. Enter the value in the box, so here, below, to make the given equation true. So this is really just a fancy way to say solve. We want to know what number do we need to replace y with so that this would be equal, this side would be equal to that one. So putting in my Great Wall of China, I can see 19 is being added to y, so I'm going to do its opposite. Subtract 19. We have y is equal to, so those cancel out. Y is its own lone wolf. And we're looking at, let me regroup. That becomes a 2. That becomes 16. 16 minus 9 is 7. 2 take away 1 is 1. So answer would be y would need to be 17. So 17 would be the number I put into the box. Do the same thing with the next one. Enter the value in the box below that will make the given equation true. All right, putting in my Great Wall of China. Here's one side of the equation that's equal to the other side. Here, x, it says we're taking 12 away. So I know I'm going to use my inverse operation, add 12. If I did it on this side, I have to do it on this side. So these cancel out. I get x by itself, which is what I want. And 2 plus 5 is 7. 1 plus 1 is 2. Answer would be 27. So to make this a true statement, x needed to be 27. All right, my final two. Write, I'm going to star that, and solve, star that, an equation for the sum of 6 1/4 and x is equal to 9 2/5. All right, I know I have to do two things, write and solve. So I'm going to make sure I get both of those done. It does say an equation, which means it has to have an equal sign. My key word here, sum, means I know I'm adding because it has to be the answer to an addition problem. And is a connecting word, which means it's going to put something together. And then we know equals is going to tell me where to put my equal sign. All right, so sum of 6 1/4 and x. So 6 1/4 is going to be connected to x through addition because I'm finding their sum. It tells me it is equal to 9 2/5. All right, there we go. Now, we need to answer this problem. So I'm going to take, first, Great Wall of China, so I have one side, my other side. It says I'm adding to x 6 1/4, so I'm going to subtract 6 1/4 from both sides. That's going to cancel that out, so I get x is equal to, and x is now all by itself, so now all I have to do is solve. I'm going to come over here and do my sidekick side work. I have 9 2/5. That's equal, oops, not equal. Let's write that again. 9 2/5. I'm subtracting from that 6 1/4. All right, as I'm looking at it right now, I can see they're not the same denominator. So you have an option of changing your fractions to be the same denominator to start and then subtracting, but I like to make them all improper fractions. That way I don't have to worry about regrouping. Your choice how you do it, but I'm going to make them improper fractions. So 2 steps, multiply and add. 5 times 9 is 45 plus 2 is 47. Fifths minus 4 times 6 is 24 plus 1, 25. 25 fourths. Oh, now from here, I know they do not currently have the same denominator. So I need to make them the same denominator by finding their LCM. Least common multiple. So 4 and 5. I'm going to start with 5. So 5, 10, 15, 20. And I'm going to stop there because I know when I count by 4, 8, 12, I'm going to eventually get to 20. So 20 is the one they have in common. The one in between would have been 16. So 20 is going to be my denominator. So then really all I have to ask myself is, what did I multiply 5 by to give me 20? Answer would be 4. So I'm going to go over here, 47 times 4. We get 8 for 28. That's 16 plus 2, 18. So it would be 188. And then over here, what am I multiplying 4 by to give me 20? That's 5. So now I have 5 quarters, so it would be 25 times 5. Or if you know 5 quarters is $1.25, so you have 125. All right, from here, I'm smiling. You can't see it, but I am. I'm smiling because I see the denominators are the same. And when the denominators are the same, it's so easy. I do the math on... I keep the denominator, 20, do the math on the top. So I'm doing 188 minus 125. All right, 8 take away 5 is 3, 8 take away 2 is 6, and 1 take away 1 is, you're right, 0. So I end up with 63 20ths. So I'm like, woohoo! Now, I look back at this and I say, hey, you know, this is improper because the top number is larger than the bottom, and all fractions are division problems, meaning how many times does 20 go into 63? Let's try that again. How many times does 20 go into 63? It goes 20, 40, 63 times for 60 with 3 left over. So now I have everything I need to make my mixed number. My answer. 3 is the whole number. The 3 pieces left over go on top of this new fraction with 20 as the denominator. That is your answer. 3 and 3/20. Now, I did say there was another way to do it where you can regroup and borrow. This would have worked out just fine if you had changed it into 20ths here, 20ths here. Come see me in class if that's the method you did, where you left it as a mixed number and subtracted. If you have questions, come see me in class. I'll go over that. All right, next. Write and solve an equation for the difference between W and 12 5/10 is 5 25/100. All right, we know we're going to write start. We're going to solve start. So we have 2 things we have to do. We know it has to be an equation, which means we should have an equal sign. Otherwise, it's wrong. It does say difference. Difference means to subtract. So something is subtracted. And I can tell here with my connecting word and that it would be W and 12 5/10 where we're going to subtract. So W minus 12 5/10. You just write it in that order how you see it because order matters for subtraction. Is a fancy way to say equal to 5 25/100. All right, so some number, when we take 12 5/10 away, it's going to be equal to 5 25/100. Put in my great wall of china so I can solve it. It says we're subtracting. I know I'm going to do its opposite. Add 12 and 5/10, which means I'm going to add 12 and 5/10 here. And I made my job hard because I didn't space it out well with decimals. Oh well. Put in the placeholder, line those decimals up, and make sure I get it right. 5 plus 0 is 5. 2 plus 5 is 7. 5 plus 2 is still 7, dropping that decimal down because that's where it belongs. And 1. Answer, W is equal to 17 and 75 hundredths. Note, for an equation, your format has to be your variable equals some value. That's how we appropriately write our solution for an equation. All right, well, that's the rest of it. See you in class tomorrow.